KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss about motion of a car on a banked road. Okay, ma? Right. So in our previous class, we focused on rolling motion and circular motion. Right? So when a body is moving along the circumference of the circle, then generally it is said to be in circular motion. But if you go in deep about circular motion, when a body is in circular motion along the circumference of the circle, two forces will act on it. Basic and the fundamental force is there itself. In that situation, centripetal force. Afterwards, based on the frame of reference, centrifugal force will act. Okay? So here, this is about circular motion. Similarly, next, rolling motion. So when a body rolls on another surface, it means that when one surface, but point of contact is very less when compared to the situation belongs to kinetic friction. In case of rolling motion, the point of contact, the area of contact by the body and to the surface is very less, right? So that is it happens in case of rolling motion, right? So just now I told you what is circular motion and what are the forces acting. What are the forces acting when a body is in circular motion? When a body is in circular motion. Afterwards, briefly I told you what happens in case of rolling motion when compared to the situation belongs to the kinetic friction, and even you can compare to the static friction. So in case of rolling friction, the area of contact between the body and the surface on which it is present is very less. That's why we prefer rolling motion when compared to the kinetic friction in different situations and in different applications of life. Okay, right. So now I am coming back to the circular motion because this class is also belongs to somewhat circular motion. How this class belongs to the circular motion means this class is about motion of a car on a banked road. Right? So what is meant by banking of roads? First we have to discuss, right? You know very well, when the road is straight, when the road is horizontal, it will be different that we completed in the last class. Motion of a car on horizontal road. But if you see the banked road, this is the situation we have to come across when we are going to take a turn. Right? So if you see that when the vehicle is going to take a turn, when it is traveling, when it is in motion on national highways as well as state highways also, whether it is 2-line or 4-line, whatever it may be, when the vehicle is going to take a turn, at the time if you observe carefully, one end is at very height when compared to the other end. So one is lower end, another one is higher end, right? You can see almost this type of difference, see here, right? So actually when the road is horizontal, it will be like this one. It will be like this. But when there is a curve, that curve has to overcome by the vehicle to go from one place to another place. At that instant of time, the road has to be banked. So that is called as banking of road. Banking of road. But now we are going to discuss what is the reason for the banking of road. Suppose if banking will not take place, what happens? Skidding will take place. Slipping will take place. So safe journey is not possible. So for the point of comfortable journey or safe journey, we need to bank the roads. Not only roads, even rail track also. When the train has to take a turn, when it is in motion along a track, definitely there should be banking for rail track. Okay, right. See this. We can reduce the contribution of friction to the circular motion of the car if the road is banked. We can reduce the contribution of friction to the circular motion. We can reduce the contribution of friction to the circular motion of the car if the road is banked. If the road is banked. Next, so what does it mean? Here we are reducing the role of friction. Reducing, not removing. We are reducing the role of friction in case of circular motion if the road is banked. If the road is banked. Next, since there is no acceleration along the vertical direction. Since there is no acceleration along the vertical direction means like this, right? So it is the road, no? So it is the vertical direction, right? With respect to the road, this is the vertical direction, but generally it is the vertical direction. Okay, for horizontal point of view, this is the vertical direction. Okay, so since there is no acceleration along the vertical direction, because the body is moving horizontally, body is not moving along vertical direction. That's why acceleration in terms of vertical direction is 0. Then the net force along this direction must be 0. So the net force along the vertical direction must be 0. When acceleration is 0, mass is not 0. Mass is not 0. Mass is present. That is the mass of car. But force is the product of mass and acceleration. No. So when acceleration is 0, automatically force will be 0. Hence, right? Okay. Now I am going to explain about this picture or figure. You just focus. See this. So it is the road on which a car is moving, on which car is taking a turn, right? So this is the tires of the car. It is the two tires are there, right? Okay, otherwise you take lorry, no problem, right? Either car or lorry, whatever it may be. Vehicle, okay? See this. So when it is on the, when it is taking a turn, see here, this is what angle of banking, right? So when there is no curvature, when there is no turn, if the road is horizontal, generally we are expecting the road will be like this, but that is also not correct. The road will not like, the bottom surface is like, what is that, plane, but the top surface will having some like this, right? So having some curvature. But in case of curvature, I mean when the road is in like an arc of a circle, then compulsory the road has to be banked to reduce the role of friction. Okay, right. So the angle of this is the angle of banking. This is the angle of banking. This is the surface of the road. It is the horizontal. So the angle made by the surface of this road, right, to the horizontal is simply called as angle of banking. Okay, right. Suppose if the vehicle needs to take a turn suddenly, then this value will be increased. If the vehicle has to take a turn slowly, means the curvature is less, then this angle will be less. That is based on our general observation. Okay, right. So come back to the point of vehicle. Now you focus on how many forces are acting. right? So you know very well, in this entire universe, the first and foremost force is gravitational force. When there is a mass, automatically gravitational force starts to act. Okay, so that's why it is mg. It is mg, and moreover it is always vertically downward. No, it is always vertically downward, so it is mg, right? Next force is normal force, which is perpendicular to the surface in contact, which is perpendicular to the surface in contact. This is the surface in contact now, so the vehicle is in contact with the surface, right? So it is the normal force, right? Okay, when this is theta, geometrical mathematics, geometrical properties of angles, okay, and here if it is theta, this is also will become theta. When it is theta and this is n, it will be n cos theta and it will be n sin theta. Here you can see this. When it is n cos theta and it is n sin theta. Okay. Similarly, the frictional force is acting in this direction, right? So when it is F and when this is theta, this is also will become theta. This is also will become theta. When this is theta, automatically you can write it as this is F cos theta and this is F sin theta. This is F sin theta, right? So actually here three forces are acting. One is weight, another one is normal force, the next one is frictional force. Based on this angle, which is, we can call it as angle of banking, but anyhow it is angle, no? So based on this angle, you can decide this one and you can decide this one. If you know this one and this one, then the force can be split into its components. So one is horizontal component, another one is vertical component. Okay, so here the horizontal component, right, it will be like this is what n sin theta and it is n cos theta. So this horizontal component and vertical component also reference, right? So the force with which it makes certain angle is generally cos theta in terms of cos theta. That's why it is n cos theta. And the force which is other than that, it is n sin theta. N sin theta. Okay. Similarly, in case of F, it is F sin theta and it is F cos theta. So including the component of forces in vertically downward direction, two forces are acting. I mean, one is the component of friction, that is F sin theta, another one is mg. In vertically upward direction, one force is acting, that is what component of n cos theta. In this direction also two forces are acting. One is F cos theta, another one is n sin theta. One is F cos theta, another one is n sin theta. Okay, right. Now come to this point. The net force along this direction must be 0. Okay, right. It's over. Hence, just by seeing this picture, right? So what can we write? N cos theta is equal to mg plus F sin theta. Mg plus F sin theta. It is the equation number 1. Next, centripetal force is provided by the horizontal components of n and F. Centripetal force is provided by the horizontal components of n and F. Okay, see here, it is the centripetal force. So in the starting of this class, I told you what are the forces will happen and what are the forces takes place in case of circular motion. The first one is centripetal force and the next one is centrifugal force. But centrifugal force comes into play with respect to the frame of reference. Okay, right. So initial one is centripetal force. Centripetal force acts towards the center. So here you can see towards the center in this direction, right? So here centripetal force is acting in this direction and in the same direction two forces are acting, right? And that is what n sin theta and F cos theta, right? So anyhow here n cos theta is equal to mg plus F sin, balancing of forces, right? So vehicle is in stable position. Means the forces which are acting on the vehicle balanced. So here n cos theta is equal to mg plus f sin theta. N cos theta is equal to mg plus f sin theta. It is the equation number 1. Next, see this. The centripetal force is provided by the horizontal components of n and f. The centripetal force is provided by the horizontal components of n and f. So here, what is the centripetal force ma? mv square by r. Centripetal acceleration is a is equal to v square by r. But centripetal force is mv square by r. So mv square by r is equal to, so this is mv square by r. It is actually, I have written acceleration, but if you want just it is a product of mass and acceleration, it will be mv square by r. So centripetal force is the mv square by r. See this. So n sin theta plus f cos theta, n sin theta plus f cos theta is equal to mv square by r. So balancing of forces, it will be equation number 2. For our convenience, it is equation number 2, right? But f is less than or equal to mu s into n. Mu s is the coefficient of static friction, but f is less than or equal to mu s into n. So from the laws of friction, you know very well, f is equal to mu into n. F is equal to mu into n. So that we are applying here. In this case, f is less than or equal to mu s into n. But to find maximum speed, that is important. So in this derivation, in this class, we are going to calculate the expression for maximum speed, maximum possible speed on a banked road, on a banked road. Okay. So to obtain maximum speed, here we have to put f is equal to mu s into n. F is equal to mu s into n. Okay. So n is the normal force. N is the normal force. Right. Now from equations 1 and 2, it is the equation 1 and it is the equation 2. From equations 1 and 2, here see this ma, n cos theta is equal to mg plus mu s n sin theta. So it is equation 1, it is equation 2, right? It is equation 1 and it is equation 2. N cos theta is equal to, n cos theta is equal to m plus mu s n into sin theta, mu s n into sin theta, right? So it is what just n cos theta is equal to mg plus f sin theta, no? In place of f, just we have written this one, that is what f is equal to mu s into n. F is equal to mu s into n. Okay. So here, just because of this equation 1 and this value, that is what f is equal to mu s into n, we are getting this. Okay. So equation 2 also you can modify it. That we are writing here. See this. N sin theta plus mu s n cos theta is equal to mv square by r. So in equation 1 and equation 2, just we have written f is equal to mu s into n. So that we are getting equation 3 and equation 4, right? It is the heading ma. There is no relation between these two. It is just like heading. I mean, this information is telling about the picture. That is what circular motion of a car on a banked road. Okay. So just from equations 1 and 2, we are getting equations 3 and 4, right? Literally from equations 1 and 2, and because of this relation, that is from laws of friction, and if you apply to this situation, f is equal to mu s into n. So if you write mu s into n, then we are getting equations 3 and 4, right? From equations 3, from equation 3, we obtain, see here, so it is the equation 3 now. So from this equation 3, we obtain mathematically, right? Just we are writing mathematically. You just divide the whole equation with n, then here it will be cos theta, here it will be divided by n, here it will be mu s sin theta. Then you take this mu s sin theta to that side, then cos theta minus mu s sin theta is equal to mg by n. Now take this n to this side and take this term, what is cos theta minus mu s sin theta, to the right hand side. Then you can write it as n is equal to mg by cos theta minus mu s sin theta. Next, substituting n value in equation 4. So this is the n value, ma. this value we are going to substituting in equation 4, right? So that will be mg into sin theta plus mu s cos theta by cos theta minus mu s sin theta is equal to mv maximum square by r. To get the expression for maximum speed, to get the expression for maximum possible speed on a banked road, we are substituting n value in equation 4, right? So if you substitute this n value in equation 4, you will get it as mg into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. Cos theta minus mu s sin theta is equal to mv maximum square by r. mv maximum square by r. Okay, right. Now here also m, here also m, both will get cancelled, this one and this one. Now we can write the expression for maximum possible speed. Maximum possible speed, it is V maximum is equal to Rg into mu s plus tan theta divided by 1 minus mu s tan theta. So it is in terms of sin and cos that we are writing in terms of tan. Mu s plus tan theta divided by 1 minus mu s tan theta whole to the power of 1 by 2, whole to the power of 1 by 2. So it is important because this expression, this derivation is important for board point of view. At the same time, this formula is important for us for competitive exams point of view, NEET, mains. So I will repeat once again. V maximum is equal to Rg into mu s plus tan theta divided by 1 minus mu s tan theta whole power 1 by 2, whole power 1 by 2. Okay, right. Comparing the above equation, so this equation, that is what equation number 5, with that equation what we discussed in our previous class, that is what V maximum is equal to, here only I have written comparing the above with V maximum is equal to square root of mu s or g, square root of mu s or g. Then we see that maximum possible speed of a car on a banked road is greater than that on a flat road. Okay, so it is the expression for what we discussed in our last class. So if we compare these two, you can say this statement, you can say this sentence. What is that? Maximum possible speed of a car on a banked road is greater than that on a flat road. Okay, next, for mu s is equal to 0, then from equation 5 mu s is equal to 0, suppose coefficient of static friction is 0, then what happens from equation 5? See this. So mathematically you just put mu s is equal to 0 here, then it is mu s, no, so 0 plus tan theta, it is also mu s, no, this will become as 0, so 1 minus 0 is 1. Then this equation 5 will become as V maximum is equal to Rg tan theta whole power 1 by 2, Rg tan theta whole power 1 by 2, right? So it is just mathematical writing, just we are putting, just we put mu s is equal to 0 in this equation, then you will get it as V maximum is equal to square root of Rg tan theta, right? Square root of Rg tan theta, right? See this. At this speed, frictional force is not needed at all to provide the necessary centripetal forces. Okay, so what is there here? R value, G value, and tan of theta. Tan of theta is the angle of banking, So at this speed, frictional force is not needed at all to provide the necessary centripetal force, Okay, full stop. Next, driving at this speed on a banked road will cause little wear and tear of the tires. Okay, generally when we are saying this word, this wearing and tearing is because of friction, but when there is more friction, then automatically we need to bear this wearing and tearing of tires as much as high. But here this is the expression, right? This is the expression which protects us from from usage of or from applying of more frictional force, right? So if you want to say it straight, with this expression at this speed the frictional force is not needed at all to provide the necessary centripetal force. See this line, frictional force is not needed at all at this speed, right? Okay. So because of that reason they cause little wear and tear of the tires. Next, the same equation also tells you that for V is less than V naught, frictional force will be up the slope, and that a car can be parked only if tan theta is less than or equal to mu s. Tan theta is less than or equal to. That is important. Okay. Not equal, not less than or equal. Anyone based on the situation, right? So both are possible. Tan theta is less than or equal to mu s. That is okay, right? So in this class, what we discussed, motion of a car on a banked road. It is the application to daily life. Okay. So in our daily life, if you see the road, whether it is 2-way or 4-line, whatever it may be, 2-line or 4-line. So when there is a turning, the road has to be banked. You can ask one question: why the road has to be banked? Yes, for the safe turning, for safe journey, for comfortable journey, the road has to be banked. But there is some other advantage. What is the advantage? Because due to if the road is to be banked, a little amount of frictional force is enough. With little frictional force, you can get the comfortable journey, safe journey if the road is banked. At the same time, you can also avoid tilting and toppling and skidding also, right? So that is the advantage of banking of road. Not only road, rail tracks are also going to bank. So that is banking of rails. Okay. So in this class, we focused to derive an expression for maximum possible speed on a banking of roads. Okay. So here we speak about, here I spoke about what is that, reduce the contribution of friction to the circular motion of the car if the road is banked. Then here there is no acceleration in the vertical direction, so that net force along this direction must be 0. Then you can write it as n cos theta is equal to mg plus f sin theta, balancing of forces. Then you can also write n sin theta plus f cos theta is equal to mv square by r, because centripetal force is provided by the horizontal components of n and f. Okay. But from the laws of friction, f is less than or equal to mu s into n. To obtain V maximum, we have to put f is equal to mu s into n. F is equal to mu s into n. Then from equations 1 and 2, you can write this one and this one also. By writing this value in equations 1 and 2, you will get equations 3 and 4, right? And from equation 3, you can write n as a subject, then n is equal to mg by cos theta minus mu s sin theta, and substitute this value in equation 4, so that we are getting expression for maximum possible speed, that is Rg into mu s plus tan theta by 1 minus mu s tan theta whole power 1 by 2. If we compare this equation with the equation what we derived in our last class, we see that the maximum possible speed of a car on a banked road is greater than that on a flat road. Suppose if you put ms is equal to 0, then from this equation, this equation will become as V maximum is equal to square root of Rg tan theta, right? So because of reducing the contribution of friction, right, in case of circular motion of the car, the wearing and tearing of the tires also little. Okay.